Recording. Okay, introduce yourselves, and Glenn has to introduce himself too.
My
So
name is
Glenn,
Zion,
And I'm Titus.
and we are working on the artificial gravity VR simulation.
Excellent.
awesome,
Our mentor is Mr. Gershner at Glenelg High School in Maryland.
awesome. So Glenn, tell them who you are. This is important.
Oh, okay. Um, so I work at Johnson Space Center in Houston, and I coordinate with a lot of the other mentors and engineers and astronauts to be able to come up with the projects that you guys are working on. So this particular one is one that we've done this several years ago, and we were able to see something exciting. But I think that as the technology develops more, I think you guys have a chance of being able to show a lot more than what our students in the past have done. But I'm very excited to see what you guys have today.
Awesome.
Okay, so tell us all about it.
So, extended periods of exposure to astronauts in zero gravity conditions can be damaging to their physical health. And some of these disturbances in their health are bone decalcification, gastrointestinal irregularities, vestibular disturbances, and a variety of others. So, to mitigate these effects, NASA, for the past few decades, has been considering a rotating space station where it would rotate fast enough to simulate gravity. And for our specific station, it would be on the outside of the station would be a one G force, and the closer you go to the inside, it would go to zero. So that when you're in the center of the station, it would be complete zero gravity. So we need to be able to render the Coriolis effect and centrifugal forces and angular momentum in our virtual reality simulation of this. And it has to enable interactive tasks such as running in both directions, throwing baseballs. It needs to be able to use a hose, and it would have to model the fluid mechanics of the water, how it would be in those conditions. And so NASA can use the simulation to train their astronauts and expose potential flaws in the design before they commit to building such an expensive station. In addition, virtual reality could offer a revolutionary way for people of all ages and regardless of physical limitations to experience space, and it could be used to teach in classrooms as well. It's also less costly than some other methods to train astronauts, and the distribution of it would be much simpler since the hardware isn't that expensive, and the distribution of the software would not be a problem at all. In addition, it wouldn't, like a lot of other training facilities, or unlike a lot of other training facilities, it wouldn't be limited to one scenario. You could simulate a variety of scenarios using just that one simulation. So this was our Gantt chart to show our progress on how we were completing the simulation. And so right now, as you can see, we're at the preliminary design review stage. After this, we will be working on perfecting it, but right now we have a mock-up. So we conducted a survey and we got 234 responses within a few days. And when we asked the respondents how useful the simulation would be, the vast majority said that they believe it will be very useful. They also said that they think it can help with astronaut training, and they understood the topic very well based on our brief explanation. So we perceive that it can be very useful, and there's a lot of public interest in this, and it seems like a worthy investment. So it's a very viable design because the platforms where you would access the simulation are very commonly available for consumers, such as the MetaQuest series of VR headsets and PSVR. Currently, the most recent one is the PSVR 2. And it also functions as a way to not only can astronauts explore this concept, but engineers and students can find a lot of functionality for this. And it can teach physics concepts such as rotational dynamics and centripetal force to students in physics classes, for example, or universities. In addition, the manufacturing and distribution is very reasonable because it's not actually physical. And so, since it is software, all it would require is a download. So we looked at a variety of prior solutions, the main one being NASA's own virtual reality laboratory training system. And so while there isn't exactly anything like our project, we found a lot of uses for specific implementations of software such as data logging and full body tracking that we would use to record forces at different parts of your body. And so these prior solutions can prove to be very effective when we're making our simulation. So ultimately, when we brainstormed our ideas, it really came down to Unreal versus Unity. And generally speaking, Unreal Engine is better for modeling larger worlds, larger scale projects. We could also find more examples of people making similar projects to ours in Unreal Engine in like Reddit forums, for example, or Unreal forums. And it's better for heavy physics modeling. And they have a specific system they use called Niagara Fluids, which is very useful for fluid mechanics. We also found it to be much easier to create higher fidelity graphics to make it seem more realistic. So our constraints and design criteria, it has to be a 15 by 3 meter toroidal module, and there has to be a central core. We made it a sphere connected by two ladder tunnels, which you can climb through to get to the zero gravity space. The acceleration must be adjustable as well, so you can change how much the station is rotating by. And we're aiming for roughly 3% accuracy at the 7.5 meter radius. We would like a realistic radial gravity gradient on all objects, and we need to be able to model Coriolis effect, centripetal force, and Euler effect, and they must deflect projectiles and fluid jets. We are using Unreal Engine 5 for this task, and the baseballs, barbell and weights, plant pillows, tables, hoses, chairs, showers, it all has to be able to be interacted with by the player character. And we also were asked to put 3 identical pendulum clocks at distinct heights to see how they would be affected differently at different heights based on the gravity. And we need to be able to display force gauges at different parts of the player's bodies to see how different parts, the head, torso, and feet mainly, are affected by different forces. The deflection error should be less than 10% when compared to our estimated prediction for test throws.
Some more constraints and criteria would be that throws predicted landing is 10%. Clocks should show visible drift over 60 seconds. And systems with logging of G-force and pendulum, the G-force and like pendulum ideas should be shown. And then the remaining remain at a stable 60 frames per second, so keeping high quality graphics during this process. So here are some of our first shell designs for our project. For the first shell, we had the ladder built directly into the system, but we hadn't added a center module. And we also had a rectangular ring-shaped design that we later smoothed out into the circular design on the left.
We also had two separate shells that we were putting together, but we later decided that it would be easier to just model the whole thing as one interconnected body.
So this is our final shell design. It is one solid shell that is smooth, then has the connecting parts with a center module that is rounded instead of being pill-shaped or cylindrical. We decided that because we did not, when you're experiencing zero gravity, it wouldn't make sense to be in a cylindrical shape. It'd make more sense to be in a spherical shape, so you can really like understand how you'd feel in zero gravity. Because in a pill shaped, you'd be kind of forced to be in either upright or upside down. But in a cylindrical, you can be in all sorts of different ways. So it'll allow you to experience the zero gravity more effectively. Here are some models that we plan on implementing into the thing, all created by me and Zion. On the left, we have the plant pillow. So this is how astronauts would generally grow plants in their environment. The reason we use plant pillows instead of pots is because in zero gravity and in gravity systems, it is harder to keep dirt and uh, soil in place. But with a plant pillow, it's constantly kept in the same location and it's easier to manage for the astronauts. Then we have a weight plate and barbell that we plan on adding to the gym portion of our design. Here are some implementation of our designs. So these are some plant pillows that we added straight into Unreal Engine. And uh, here is a model that of a non-player character, an NPC for short, that we added to the design where we actually changed the forces affecting it. And it is, instead of falling downwards, it's falling directly into the mesh, which is holding it up instead of falling down towards gravity. Here is a video of our space station rotating. And then these are the refining of our prototypes. So on the right, you can see the rectangular design that we showed at first, and then we decided to move to a more torus-shaped design with the pill-shaped center module. But then we decided to change the gravity compartment into a rounded shape, which overall looks much better. And then now we're working on translating the CAD into the design, as you can see on the picture on the left.
So what we're going to work on next on the simulation is, first we want the interior to look more how it would look like in real life, not just be just blank white. We want to make it as realistic as possible. In addition, we want to make it more usable for a player that you would directly control instead of a non-playable character like we showed previously. And so we are trying to implement ghost effect, which would be basically, for example, if you throw a baseball in one direction and then throw it in a different direction at a different trajectory, you would be able to see the previous throw and then compare the two and see how different things are affecting it. In addition, this is obviously the hardest part, but improving the actual physics of the station, that's the main part of this project, and improving fluid simulation, because when you're using a hose, the water's not going to fall straight like it would on Earth. It's going to go in a variety of directions based on where you're using it in the station.
Here's the estimated goal for our final project. We plan to have the full artificial gravity simulation completely finished by the beginning of January, and we want to have all the tasks implemented into the gravity system by the beginning of February to have a full completed project done by then. Any questions?
Wow, I'm impressed. I'm always
Very
impressed. How do you have all this knowledge already? Did you guys study virtual reality or play the games or do anything?
I don't have
Or
he has access to virtual reality headsets. He has two of them. I've had experience before. Actually, there's a careers class at Glenelg High School, and one of my teachers was nice enough to let me participate. And there was this virtual reality simulation they had where it was like simulating different tasks, like Mr. Gershner was mentioning previously, like welding or blowing up something to
yeah,
the bridge or something like that.
Wow.
and
So,
I
yeah.
want Nancy, introduce yourself, please,
Oh,
before
hi,
you
I'm
ask.
Nancy Hall. I'm the regional mentor at the NASA Glenn Research Center in Cleveland, Ohio. So I work with schools in my area, which includes Michigan, Minnesota, Wisconsin, Missouri, Ohio, and parts of New York. So, and I help out Flo. Tying to Flo's questions, have either of you programmed in using Unreal Engine or Unity before? Or
Not
are
for
you
this
doing that?
project, but I've been primarily working on the coding and developing of the Unreal Engine simulation.
Okay, so
Uh,
you've worked with that before, so you have some experience using that.
this
Oh
is
no,
my
so you're
first
just
time using
starting. Okay,
it
cool.
is a very difficult, but it is a fun project that this allows me to actually experience this, which I
Mhm.
believe Unreal Engine can be used in a lot of different simulations.
Oh yeah, yep.
And kind of gives me a like stepping stone if I
Mhm.
wanted to translate instead of engineering into something like game design or software engineering.
Oh yeah, definitely. Those are two of the um engine systems students use, and students have used both for different reasons. So I like looking at seeing what you guys decided and why you picked the different ones. So I like what you had stated about why you went with Unreal Engines, mainly because of the science and the work and the applications it has that you're able to use these. So that's real good. And I came in a little bit in the middle of you. Did you guys show a Gantt chart that laid out how you were doing everything?
We
Yeah,
did.
we did.
Okay. No, that's real good because one of the things I usually tell students with this is you want to try to put things a little bit at a time, and having that Gantt chart is good because you can also see when you're falling behind, because sometimes putting an object or trying to get something to work, or like you said, getting the physics can get tough. So don't be afraid to get halfway there and then realize, hey, this isn't working. Don't keep trying to get it to work perfectly. Go on to the next step, get to the next object, because you may be able to get all the others going. But if you like get stuck in trying to make sure the baseball move correctly, you may miss out on the other items.
That's really good advice. And I love that you're not procrastinators because
Yes.
you wanted to get that done in the beginning of February. You know, your critical design review is until the very end of
And yeah.
February. So that every time you made a deadline, you made it ahead of time, which is really good. But that advice Nancy just gave
Yeah.
is really important. That's from
You guys,
experience, I would think,
Yep.
Nancy.
Yeah.
can you go up a couple of slides so we can look at your design? There you go.
Yeah, the one right
Oh,
there
what,
after this.
This
what's
one or
play that again? Remind me of what this is.
oh,
Oh,
this
okay.
was the video.
Yeah, this is
Okay.
So this is a video of me getting the system to spin,
Okay.
and then from that point we need to add the internal structures into the
Uh-huh.
so that would be like baseballs, gym equipment, and the plant pillows are some of the things we would start adding into there.
Mm-hmm.
I've been experimenting with it, and that is using a rigid motion and a circular rotational motion. Blueprint is how I made that. And I would have to take that blueprint and I would have to basically add all the internal fixed structures. So that'd be stuff like tables and stuff that aren't going to be able to move in the project. But I would then have to take that and add all those features into the rigid motion. And then I would have to take the soft objects, and I would have to use a different mesh. I think it's a flu. It's called fluid motion, I believe, to be able to move around. freely in that space and actually experience the centrifugal force.
Okay. All right. And go back to the overall shape of the module.
Yeah, the next slide. Yeah.
Okay. All right. And I'm interested in so you went from a cylinder in the middle to a sphere, and you talked a little bit about that. Can you go over that again for me?
So in zero gravity, you're not really, you shouldn't really be, we decided that you shouldn't really be fixed into like an upright or into like a set position. You should be able to experience it in a more organic way. And because of the cylinder shape, it kind of forces you to be in like one specific like plane. So like either upright or like how it would be is for us is upside down or upright. But in a cylindrical, you could be all different ways and move in it in a much more organic and natural way.
And so I'm not opposed to letting you do that, but some things that you'll want to think about is one, you have to have I chose a cylinder because that's what we currently use, but we also need a way to get in and out of it. And right now, you don't have any hatches or anything for how it would launch, how it would dock to other vehicles, and things like that. And so, go ahead and continue with this, but make sure you add in some of those other features for how we're going to get into it. The other thing is on the inside, where would you put your lights?
Lights, well, it would be placed sporadically throughout the torus, right?
So yeah,
Right. Well, the torus is one thing, but in the sphere, it's a different thing. And part of why I'm bringing that up is that inside of the space station, um, the crews, the astronauts wanted to have something that helped them determine which way was up, so that it was something consistent. And when you have a sphere, that could make it a little bit complicated. So, again, I'm okay with you starting off with a sphere for that central core segment, but think about how those things are going to work as you progress with that. Okay.
understood.
Now, let's see. I on that video or on the picture where you have somebody standing inside, I think that looks terrific. Some of the other things that I've seen from the past that may be helpful is to have some directions on the floor. So, for example, you might have like some kind of arrows that are describing which way it's rotating, because we'll find out that that may cause some difficulties in terms of, or not having it can cause difficulties with which way things are going to turn when you're like squirting water or things like that. Okay.
Okay.
All right. I like what you're doing. I think you've got a really great start. Um, have you found so one of the difficulties that they encountered in the past was making it so that the gravity gradient was radial as opposed to choosing a more traditional down. Have you had difficulties with that, or is that something you're still looking at?
We're still looking at it. I've been trying to experiment with it, but have been having difficulties because it's not just like you can just throw the equation in and the system knows. You kind of have to engineer around the equation, which is the major challenge right now with that we're working. That we're
Understand. And so you might look and see if you can do a Google search for it. You might find that somebody else has approached this and they might have some solutions as to how to do it with Unreal Engine, or they might have had done something with Unity, and it might relate a little bit. Okay. I wish I had some more advice for you there, but I know that this is going to be one of the challenges. Okay.
Yeah. Thank you.
We've had one of our previous mentors was related to somebody from Unreal Engine, and they were surprised. We had a couple of students who had solved that issue, and the Unreal Engine person was pretty impressed because he did not know that it was even possible. So
Yeah,
it's not going to be an easy task,
yeah.
but
Glenn was, yeah.
also don't let that be your only thing that you're working on. There's lots of other tasks. Okay.
Okay.
Hey,
What were
Glenn,
you
was
saying?
this? I was gonna say, is this the student that was using cylindrical coordinates to try to solve the one gravity equation vector?
It probably was, but I
Okay,
don't remember.
okay.
Um, and it might have been somebody from Glenelg last time, but I don't remember. So you might ask your teacher if there was anybody who had worked on this previously and if you might be able to contact them. Okay?
He did mention there was one student, I think 2 or 3 years back, who worked on VR.
And it wouldn't, that person is probably off in college right now and might be willing to come back and talk to you a little bit about what they had done. That would be terrific. Okay. So are you guys having fun with this?
I am, yeah. It's a fun, but it's difficult. It's very,
Well, I am so glad you're working on this. This is one of the projects that I'm really excited about what kind of future it has, and the fact that somebody else is picking this up and is excited about it, it makes me feel terrific. So keep going on this. All right. All right.
Awesome. Do you have any questions for us?
You have it?
I don't.
No, I think we're fine.
Okay, you
Okay.
can always send us questions and then I can send them to Glenn. But copy your
Sure.
teacher. Copy your teacher on that. And you mentioned that they could do a Google search, but could they do a AI search?
Yeah, that's actually a great idea. You might be able to get some help from AI to be
Yeah.
able to help to be able to determine some of this. It may even be able to give you some of that some of the code that you're looking for that. So that's actually a great idea, Flo.
Yeah, well, I'm so modern, right? You might as well go to AI.
Um, so one of the other things I wanted you to think about though, and I don't know how this will play out, but imagine if I take cargo, um, some equipment or supplies or whatever, and I bring it from the central core area and then take it outward. You can imagine that depending on the mass of that, um, one, as I take it out there, it's going to slow down the rotation in the same way that when an ice skater is spinning around and puts their arms out, that's going to slow down their spin, right? Well, if I take cargo and I move it from the central area to the ring, well, then it's going to slow down that ring. But it's also interesting because I'm as I do that. Um, as I go from the central area out, it's going to take a significant amount of time for me to do that. And so it may actually cause some wobbling in that rotation as you go down. And so there's all kinds of things that we have to start thinking and learning about that's relevant to this kind of toroid and spinning. And so as you're developing this, be thinking about some of those other engineering problems that we might be encountering. Okay.
Okay.
Understood.
You guys are terrific. I am so excited that you're working on this.
Thank you.
Thank you.
Yeah, I'm
Oh,
glad you chose it.
hey, one other thought for you. Um, I don't want you, there's so many things that you can download from whether it's Thingiverse or whether it's from, all these other sites. You don't have to build everything. If you go on some NASA sites, you might be able to find some already existing, like spacesuits or things like that you might want to fill out the inside with. And it's perfectly fine with me for you guys to find things so that you don't have to develop all of those parts. Okay?
We actually did we didn't show it in this presentation because it was kind of trivial, but for the chairs and the the tables, we did that specifically. We found it on a free use database.
I think that's terrific. That's perfectly fine with me. And outfitting it like that, it makes perfect sense.
The one we used specifically was thangs.com.
Oh, okay. Very good.
Yeah, and that was the other comment I had. I didn't say, but definitely if you have places where you can get shareware, the the baseball, the plants, anything, that's a great way to do it. The one comment is when you do your presentation, if it's a location, just note it on your presentation or poster that you got these items, or if you do a report, so that way the proper person can get the credit. But there's lots of places that provides that, and it definitely will save you time. I mean, trying to design it is great, but if there's things, normal objects that's going to go there that you can just find, plop in, and there's tons of them out there, that makes it a lot easier.
Oh, yeah. I agree with you completely.
Mhm.
Okay. Any other thoughts, gentlemen?
Good. No.
Awesome.
All right. Thank you for working on this. I'm very excited.
Thank
Yep.
you for listening to us.
Yeah, thank you.
Thank you so much, and you'll have a wonderful afternoon there.
You too.
And thank you, Glenn and Nancy, for joining us. The only
Thanks, Nancy. Good to see you.
Yes, so we canceled, Nancy, we canceled the Bozeman team that was going to present today.